Hey everyone, and welcome back for another deep dive. Today, we're going to be talking about something that I think you'll find pretty electrifying.
Oh, I see what you did there.
We're going to be talking about AC
But
generators.
those are pretty important.
They are. We use them every day. You've sent over some really cool stuff from like an educational website about AC generators.
Yeah, they have this really cool 3D model that we can use to sort of explain what's going on.
It's going to be really interesting to break down how these things actually work.
Yeah, you take it for granted. You just flip a switch and the lights come on.
Right. But there's so much more to it than that.
Yeah, a lot more.
So let's get started with the basics. What is an AC generator?
Well, it's a device that uses magnets and wire to generate electricity.
Right. But I remember from science class that magnets have like a north and south pole,
Uh-huh.
right? And they attract or repel each other. What's actually happening inside the magnet to create that force?
So you're talking about magnetism there, which is a fundamental force of nature. And it all boils down to electrons.
Electrons.
Yeah, those tiny little charged particles that orbit the nucleus of an atom.
Right. Yeah.
And each of those has a property called spin, and that spin creates a tiny magnetic field, like a miniature bar magnet.
So it's like every electron has its own little magnetic field.
Exactly.
That's crazy. Okay, but if everything's made of atoms with electrons, why isn't everything magnetic?
Well, because in most materials, the magnetic fields of the individual electrons are oriented randomly so they cancel each other out.
Oh, okay.
But in a magnet, the atoms are structured so that the spins of their electrons align, creating a unified magnetic field that's much stronger. So it's like you have billions of tiny compasses all pointing in the same direction.
Okay, so that makes a lot more sense. So this powerful magnetic field in the generator is what interacts with the spinning wire coil, right?
Right.
But how does spinning a coil in a magnetic field actually create electricity?
That's a great question. So that process is called electromagnetic induction, and it was discovered by Michael Faraday.
Oh, yeah, I've heard of them.
Yeah, back in the 19th century. And what he found was that a changing magnetic field can induce something called an electromotive force or an EMF in a conductor.
EMF.
EMF, and that drives the flow of electric current. It's like if you're pushing a swing, you need to give it a push to get it going.
All right, to get it started.
And that push is the EMF.
Okay, so the changing magnetic field is key here.
Yeah.
But in this 3D model, the magnets are stationary. So where's the change coming from?
The change is coming from the spinning coil. So as the coil rotates through the stationary magnetic field, the number of magnetic field lines passing through it are constantly changing.
Okay.
And that's what induces the electric current. Think of it like moving a magnet in and out of a coil of wire.
Okay. Yeah.
That back and forth motion is creating a changing magnetic field.
So it's the relative motion between the coil and the magnetic field that matters.
Exactly.
Okay, so we've got this spinning coil creating an electrical current. But is there any resistance to this process? I mean, doesn't nature usually push back when we try to do something like this?
Yeah, you're exactly right. And that pushback is described by something called Lenz's law.
Lenz's law.
Yeah, and what Lenz found was that the induced current actually generates its own magnetic field, but in a direction that opposes the change that caused it.
So it's like the induced current is trying to fight back against the very thing that created it.
Yeah, exactly.
Does that mean there's some kind of energy loss in the generator?
Exactly. So it's kind of like a magnetic tug of war.
Oh, wow.
And that's why generators require a continuous input of energy to keep them spinning. They're constantly working against this opposing magnetic force. And this is also why if you've ever ridden a bike with a generator-powered light,
Oh, yeah.
it gets harder to pedal when the light is on. You're literally feeling that resistance from Lenz's law.
That's a great way to put it. So it's all about balancing the forces to get that flow of electricity. But we keep saying alternating current. What makes it alternating, and how is that different from, say, the direct current from a battery?
Right, so the current alternates because as the coil rotates within the magnetic field, the direction of the induced current keeps switching back and forth.
Okay.
So if you imagine a point on the coil moving upwards through the field that induces a current flowing in one direction, but as that point rotates downwards, the current reverses direction.
Okay.
And so that continuous change in direction is what defines alternating current, or AC.
So that wavy line we often see representing AC, the sine wave, is showing us this back and forth flow of electricity.
Exactly. It's
Okay.
showing the fluctuating voltage in AC electricity. I see. So the coil is generating this alternating current, but how does it actually get out of the generator to power our devices?
Looking at the 3D model, I see those rings on the end of the coil. What are those for?
Those are called slip rings,
Slip rings.
and they play a critical role in extracting the alternating current from the spinning coil.
Okay.
So as the coil rotates, the slip rings maintain a continuous connection to the external circuit
Okay.
through brushes that slide against them.
Interesting.
And that allows the alternating current to flow out of the generator and into the power grid.
It's amazing how these simple components work together to create something so powerful.
Mm.
Okay, so we've got the magnets, the spinning coil, the slip rings. Is there some kind of formula that ties all of this together and tells us how much electricity we can actually generate?
Yeah, so the amount of electromotive force, or EMF, induced in the coil depends on several factors, and it's captured in a pretty elegant formula. The EMF is equal to the negative rate of change of magnetic flux multiplied by the number of turns in the coil.
Okay, break that down for me. What does that actually mean in terms of the physical components?
Sure, so basically it means that the amount of electricity generated depends on the strength of the magnetic field, the area of the coil, and how fast the coil spins.
Okay.
So a stronger magnet or a bigger coil or faster rotation will all lead to a higher EMF and therefore more electricity.
I'm kind of in awe of how this all works. You have these basic elements, magnets, wire, motion, and then you have this simple equation that connects them to this incredible outcome.
Yeah.
Electricity that powers our entire world.
It really is amazing, isn't it?
Speaking of applications, it's safe to say that AC generators are pretty much everywhere,
Yeah.
right? I mean, it's not just about plugging in our phones and laptops.
Yeah, you're absolutely right. AC generators are the backbone of our modern electrical grid. From massive power plants that generate electricity for entire cities,
Right.
to the portable generator that you might use for camping.
And given the global energy crisis and the increasing need for cleaner energy sources, AC generators seem even more crucial today, right? I mean,
Yeah.
I know that wind turbines and solar panels are becoming more common,
Yeah.
but how do they fit into the picture?
That's a great question. Renewable energy technologies like wind and solar power rely heavily on AC generators to convert the energy they capture into a usable form.
Okay.
So, for example, a wind turbine uses the wind to spin blades, which in turn rotate a shaft connected to an AC generator producing clean electricity.
So even though wind and solar power are very different from burning fossil fuels, they still rely on these same fundamental principles of electromagnetism and AC generation to deliver electricity to our homes and businesses.
Exactly.
And this is where the story of AC generators gets really interesting, because back in the late 19th century, there was a fierce rivalry known as the War of the Currents between Thomas Edison, who championed direct current, and Nikola Tesla, who advocated for alternating current.
Wow, I did not know that.
So there was a time when people weren't even sure if AC was the best way to deliver electricity.
Absolutely.
Okay.
Edison believed that DC was safer and more efficient.
Okay.
But Tesla argued that AC could be transmitted over much longer distances with less energy loss,
Oh,
making it more practical for large-scale power distribution.
I see.
And ultimately, Tesla's vision prevailed, and AC became the standard for electrical grids worldwide.
Wow, I had no idea about this War of the Currents. It's
Oh.
fascinating to think about how the technology we take for granted today was once the subject of such intense debate and competition.
It just goes to show that scientific progress is often driven by these clashes of ideas and the relentless pursuit of better solutions. And speaking of solutions, there's another aspect of AC generators that I think you'll find quite intriguing.
Ooh, I'm always up for more intriguing insights. What else is there to uncover about these amazing machines?
Well, we've been talking about how AC generators harness mechanical energy to create electricity, but what if that mechanical energy came from us humans?
Whoa, you mean like humans actually powering generators with our own bodies?
Yeah.
Is that even possible?
It is. Remember, mechanical energy is simply the energy of motion. Every time we move, we're generating mechanical energy.
So theoretically, we could hook ourselves up to a generator and become like human power plants.
In a way, yes.
Yeah.
You might have already seen human-powered generators attached to stationary bikes at the gym,
Oh, yeah.
or hand-cranked generators used in some portable devices.
That's pretty cool. I could see how that would be useful in emergencies or in areas without reliable access to electricity.
Yeah.
But let's be realistic. How much power can a person actually generate? I'm no Olympian, so I doubt I could keep the lights on for very long.
You'd be surprised the average person can sustain an output of around 100 watts for a decent amount of time.
100 watts.
Oh.
What does that translate to in terms of, say, powering household appliances?
Well, it's enough to power a few LED light bulbs, charge a laptop, or run a small fan.
Okay, so maybe not enough to run my entire house, but still pretty impressive.
Yeah.
It's fascinating to think that our everyday activities could actually contribute to our energy needs.
Exactly. And while it's unlikely that human power alone will solve the global energy crisis, it does offer a unique perspective on sustainable living and energy conservation.
I see what you mean. If you had to pedal a bike to generate the electricity to watch TV, you might think twice about binge watching an entire season.
Precisely. There's something about physically generating your own power that makes you much more aware of how much energy you're using. It creates a direct connection between your actions and their energy consequences.
That's a really interesting point. It's easy to take electricity for granted when it's just there at the flip of a switch. But if you had to put in the effort to generate it yourself, you'd definitely be more mindful of how you use it.
And that shift in mindset, that awareness of our energy consumption is crucial as we face the challenges of climate change and resource depletion.
This whole discussion has me thinking. We started with AC generators,
hmm
and now we're talking about human power and the future of energy. It's amazing how interconnected everything is.
That's the beauty of the deep dive. We often start with a specific topic, but it can lead us down all sorts of unexpected paths and reveal surprising connections. Speaking of surprises, the source material mentioned that even a simple hand crank could generate enough power to light a small LED.
Really? That's wild. Imagine using a hand crank to power a reading light while camping, or even to charge your phone in an emergency. That would be super handy.
Exactly. It highlights the potential of human-powered generation, even on a small scale. And it raises some interesting questions about how we might integrate these types of technologies into our lives in more creative and sustainable ways.
This has been such a thought-provoking conversation. But I have to admit, I'm still a bit baffled by the whole idea of electrons spinning and creating magnetic fields. It's just so mind-boggling.
It is a bit of a head-scratcher, isn't it? The world of quantum mechanics, where electrons reside, operates by very different rules than the everyday world we experience.
Okay, so maybe asking you to explain electron spin is like asking you to explain the universe in 5 minutes.
Yeah.
But is there anything else you can tell me about these amazing little particles that might help me wrap my head around it a little better?
Well, one way to think about electron spin is to imagine it as a fundamental property of the electron, like its charge or mass. Just as an electron inherently has a negative charge, it also
Yeah.
inherently has this property called spin, which creates a magnetic field.
So it's not like the electron is physically spinning like a top.
Exactly. It's a quantum property that we can't fully visualize in terms of our everyday experience, but we can observe its effects through the magnetic fields it creates.
Okay, that's helpful. So the magnetic field is like the electron's way of announcing, hey, I'm spinning over here.
That's a good way to put it. And in magnets, as we discussed earlier, the key is that billions of these tiny spinning electrons align their magnetic fields, creating a much stronger, unified magnetic force.
This is all so fascinating. It makes you appreciate the incredible complexity and elegance of the universe, even at the tiniest levels.
It really does. And it's this
Yeah.
understanding of the fundamental forces of nature, like electromagnetism, that has allowed us to develop technologies like the AC generator, which have transformed our world.
Speaking of transforming the world back to human-powered generators for a moment, are there any large-scale applications of this technology being explored? Or is it mainly limited to small individual devices?
That's a great question. While large-scale human-powered generation might sound far-fetched, there are some really innovative projects underway. For example, some companies are experimenting with dance floors that generate electricity from the movement of dancers.
Wait, so you could power a party just by dancing? That's amazing. What a fun and sustainable way to celebrate.
Exactly. And it's not just dance floors. There are also projects exploring human-powered generators in gyms where the energy from exercise equipment could be captured and used to offset the gym's electricity consumption.
Wow, that's brilliant. It's like turning our workouts into a source of clean energy. I love how these ideas are blurring the lines between our everyday activities and our energy production.
It's a fascinating trend, and it speaks to the growing awareness of the need for creative and sustainable energy solutions. And as we continue to explore the possibilities of AC generation, who knows what other innovative applications we'll discover.
I'm already eager to see what the future holds.
Yes.
But for now,
I think that.
I think my brain needs a moment to process all this amazing information.
I hear you. It's been quite a journey exploring the world of AC generators, from the tiniest electrons to the largest power plants.
Welcome back, everyone. I feel like my brain is still kind of buzzing, from all the amazing things we've learned about AC generators.
It has been quite a deep dive, hasn't it? We've covered so much.
Have, from like the basic principles of electromagnetism
Yeah.
to, the complexities of electron spin.
Uh-huh.
And we even, touched on the potential of human power generation.
It's amazing how much we've packed into this deep dive.
Right. And we even uncovered some, fascinating historical tidbits along the way.
Yeah.
Like the War of the Currents
Oh, yeah, between Edison and Tesla?
between Edison and Tesla. Who knew that the electricity we use today was once the subject of such fierce debate?
I know, it's fascinating, isn't it?
It is. Speaking of innovations, though, I'm really intrigued by these creative applications of human power generators we were just talking about.
Yeah, me too.
Like dance floors that generate electricity.
It's pretty amazing.
Gyms that capture energy from workouts. I mean, it's like something out of a science fiction movie.
It does feel a bit futuristic, doesn't it?
It does,
Right.
but it also, highlights, I think, a growing trend of integrating these sustainable energy solutions
Right.
into our everyday lives.
Yeah, in ways that are engaging and fun.
In ways that are engaging and fun, exactly. And I think that's a key point. It's not just about, finding these alternative sources of energy,
Right.
but also about changing our relationship with energy consumption,
Absolutely.
how we think about it, how we use it.
Yeah, I think when we actually participate in generating our own power, even in small ways, it fosters this deeper appreciation for, the effort and the resources that are involved.
And it makes you think twice about leaving the lights on
Yeah,
or, letting the TV run in the background.
for sure, for sure.
Okay, we have to ask, what's the most surprising or unexpected thing you've learned about AC generators in your research?
Oh, that's a tough one. I think what continues to amaze me is the sheer scale of impact AC generators have had on our world.
I agree.
It's easy to forget that just over a century ago,
Right.
electricity was a novelty, something that only, a privileged few had access to.
Yeah.
And today, it's so deeply embedded in our lives that we take it for granted.
You're so right. It's like trying to imagine life without the internet now.
Yeah.
It's almost impossible. But none of it would be possible without these AC generators, humming away behind the scenes,
Yeah.
quietly converting motion into the electrical energy that powers our entire civilization.
And to think,
No.
it all goes back to those fundamental principles of electromagnetism we were discussing.
Right.
The interaction between magnets and a moving coil of wire.
Yeah.
The magic of electromagnetic induction.
It's truly remarkable. It's like a symphony of, science, engineering, and human ingenuity,
Yeah.
all coming together to create something that's both powerful and essential to our modern world.
Beautifully.
And it's a symphony that continues to evolve right as we explore new technologies
Right.
and push the boundaries of what's possible with AC generation.
Absolutely.
Speaking of pushing boundaries, the source material did mention that AC generators are at the heart of many renewable energy technologies. And we talked about wind turbines, but what about solar power? How do AC generators fit into that picture?
So solar panels actually generate direct current or DC electricity,
Okay.
but most of our appliances and the electrical grid itself operate on AC. So to use solar power effectively,
Yeah.
we need a device called an inverter
An inverter.
to convert that DC electricity from the solar panels into AC.
That makes sense.
Yeah.
So even though solar panels don't have, any moving parts or magnets like a traditional AC generator, we still need that AC conversion to make the most of solar energy.
Exactly. And I think this highlights another important aspect of AC electricity.
Okay.
Its versatility.
Oh, yeah.
It can be easily transformed to different voltages, making it ideal for long-distance transmission and distribution.
So the same principles that allowed Tesla to win the War of the Currents over a century ago
Right.
are still relevant today
Yeah,
as we transition towards these cleaner and more sustainable energy sources.
absolutely.
This deep dive has been a truly enlightening journey. We've learned so much about AC generators, from the tiny electrons that create magnetic fields to the global impact of these incredible machines.
It's been a pleasure sharing this journey with you.
Likewise.
And I hope our listeners have gained a newfound appreciation for the science and technology that powers our world.
I think they have. I hope so too. But before we wrap up, I do want to leave our listeners with one final thought.
Okay.
We talked about how AC generators work,
Uh-huh.
but the source material mentioned that the current produced is constantly alternating directions.
Right.
Why do you think that's important? What advantages does alternating current offer? We'll leave you to ponder that. Until next time, keep exploring, keep questioning, and keep diving deep.